Alright, so I'm here to share with you this part of the chapter. Please get ready for our lesson. Make sure you have my notes with you on the table. Pause the video if you need to. Okay, so now that you're all ready, let's carry on with the lesson. Let's talk about the harmful effects of electricity. There is always the risk of electrical hazard when we use electricity improperly or because of wear and tear of the components. Hazards, example of electrical hazards are electrical fire and electrical shock. Both are nasty things to happen. So what is electrical fire? It's a fire that is created because there is a lot of current flow. So we call it electrical fire. When current flows through a wire, it actually heats up the wire. So when there is a lot of current flowing, the heating effect will be very, very big. And what causes this? A very common reason for electrical fire is because we overuse our multi-plugs or power extensions. When we put multi-plugs and we connect many appliances to one socket, what we are doing is, every single of these plugs that we connect, every single electrical appliance that we connect, actually draws a certain amount of current for you to run that device. If you connect like 10 appliances to one plug, you have 10 devices drawing current from the plug itself, from the circuit in the plug itself. So that poor plug, the poor wall outlet will have to supply current to 10 devices. You just add up all this current, it will amount to a super big amount of current, and that's when the heating effect of this current that is flowing in the wall plug or in the wall outlet becomes very, very big, very, very hot. And when this happens, the wires within the wall outlet or within a multi-plug actually can't withstand this heat. It will start to burn, and that is what creates electrical fire. Now, electrical shock, I think I have experienced this before. When your charging cable is exposed, sometimes you just get a slight shock. This can be very dangerous. So we must ensure that our wires are insulated well. This often happens, what is shown on the picture here often happens to charging cables, and if this happens, please do not use it anymore. Okay. Now, water is actually an electrical conductor, and that's why since young our parents always tell us not to switch on the switch with wet hands. Don't operate any devices where your hands are wet. Dry your hands first. I have a friend who is a teacher here in the school also.
It was the story that stunned the nation.
Was electrocuted
a 14-year-old girl
because
electrocuted
he touches the switch and switch on the switch with wet hands. He's okay, he's
You're not
perfectly fine,
supposed to bury
but
your
it was a
babies.
nasty shock
Madison Coe's
in
family
every
says
sense of
soaking
the
in the
phrase.
bathtub while
Okay?
listening to music
So
and
just be
playing
careful of
games on
this.
her phone was one of her guilty pleasures.
Went in to tell Maddie that
Let's
it was
watch
time
this
to get
video.
out, so we could go to bed.
A 14-year-old girl
And I called her name. She didn't answer.
They found Maddie in the
It's a
tub.
bad thing to do.
Stepmom and father, both medical professionals who know CPR, tried all they could to revive her, but it was too late. Electrical engineer Steve Fowler set up this demonstration with our Lisa Guerrero. What exactly happens when you accidentally drop a cell phone in the water?
We're reading nothing, absolutely zero.
Okay, so just dropping a phone by itself into a bathtub is not going to kill anybody.
No.
So far, so good. But what happens when the cell phone is attached to an extension cord, particularly one that's frayed, which is exactly what happened to Madison.
So now the frayed cord is in there.
The electricity is off the charts.
Oh boy, it's moving.
Yeah, so that's,
Wow, this person would be dead in the bathtub right now.
that's right. This person would be dead.
The same thing happens when we drop other common bathroom items into the bathtub, like a curling iron,
Oh boy, it's going crazy.
a hair straightener.
The entire tub is electrified.
It's moving.
In case the message isn't clear enough,
Anything plugged into the wall should not be near a bathtub.
that's a message this grieving family would like to echo.
We're all so attached to our cell phones and our electronic devices and games, and our beautiful angel is
The
gone.
entire tub is electrified.
In case the message isn't clear enough,
Anything plugged into the wall should not be near a bathtub.
that's a message this grieving family would like to echo.
We're all so attached to our cell phones and our electronic devices and games, and our beautiful angel is gone.
It's actually a very sad story. So let's learn from the mistakes of other people and don't ever do this. Okay? Now this is pretty common sense. Don't ever insert our fingers or anything basically into a power socket. Be very careful because there are this kind of 3-pin plugs where if you want to insert a 2-pin plug within the wall socket, it just can't go in. So you need to sort of release a lever in the top hole for the 2-pin plug to go in. And something that people commonly do is to use a pen to sort of poke it inside the top hole for you to release the catch so that the 2-pin plug can go inside the wall socket. My advice is not to do that. First is a bit difficult to release the catch using that method. Second, it might not be very safe. Therefore, if you have 2-pin plug and you can't manage to plug it in, always have this kind of 2-pin adapter that you see on the slide. Once you put it in, you'll make it very easy to go for the 2-pin plug to go in. Alternatively, if you don't have this 2-pin adapter ready, what you can do is you just find any multi-plug, and then when the multi-plug is disconnected, you can use whatever pen you want when it's disconnected to sort of release the catch in the top hole for you to insert the 2-pin plug into the multi-plug. So once you've done that, then you attach the multi-plug into your wall socket before you on the power. That would definitely be safe because you are poking the pen into the multi-plug when the multi-plug is not plugged in yet. So that's a daily hack. Alright, now let's look at some electrical safety precautions.
Stay safe together. Hey there. Psst. No, down here. Shocked? Don't be. I'm just the outlet you need to turn on the lights, watch TV, charge your phone, even play games on the computer. They all run through me with electricity. But I'm here to tell you that electricity can run through a lot of other things too, because it's always trying to get to the ground as fast as possible. So it'll travel through conductors like metal, water, wood. Electricity can even travel through you too. That's why you've got to play it safe and sound when electricity's around. So come on, come in.
In there?
Sure. Let's explore my top 5 that can keep you alive. Let's see. Why don't we start with
How about number 1?
number 1? That's a good place to begin. It's simple. Never, ever, ever stick metal objects into an outlet or anything running on electricity, like a computer, a game, or stay safe together. Like a toaster.
Yeah, I like to eat.
Hey there.
But I don't want to be toast.
Okay. Number 2. No, down Don't here. Put too many plugs into one. Shocked? Don't be. I'm just the outlet you need to turn on the lights, watch TV, charge your phone, even play games on the computer. They all run through me with electricity. But I'm here to tell you that electricity can run through a lot of other things too, because it's always trying to get to the ground as fast as possible. So it'll travel through conductors like metal, water, wood. Electricity can even travel through you too. That's why you've got to play it safe and sound when electricity's around. So come on! Come in!
In there?
Sure! Let's explore my top 5 that can keep you alive. Let's see. Why don't we start with
How about number 1?
number 1? That's a good place to begin. It's simple. Never, ever, ever stick metal objects into an outlet or anything running on electricity, like a computer, a game, or especially an old kitchen appliance, like a toaster.
Yeah, I like to eat toast, but I don't want to be toast.
Okay, number 2. Don't put too many plugs into one outlet. There's a reason why each outlet only has 2 plug-ins. Using any more than 2 could spit sparks and start a fire.
So, if I need to plug in more, I'll always use a power strip.
3. Water mixes with a lot of things, but water and electricity, they don't mix.
They never have. They never will.
So to avoid a really shocking accident, that means no hair dryers, no phone, or game chargers, nothing plugged in near a tub or sink full of water. Play it so safe that you never even touch an electric switch when you're wet.
And hey, that means no radios near the pool either.
Number 4 is so easy you won't even have to look it up. Just look up,
Oh, you mean stay away from power lines.
especially during thunderstorms. Strong storms and wind can damage power lines, and if you see that happen, wow, get back.
And I'll get to a phone and call OG&E as fast as I can.
The same goes for power lines damaged in a car accident.
That means steer clear.
And if you're in a car and power lines are touching it, don't get out. You're actually safe in the car. But if you do need to get out, jump as far as you can without touching the car and the ground at the same time. Just remember, sagging power lines or lines knocked to the ground are dangerous.
Alright, so the talking power plug is actually, or power outlet rather, is actually quite scary. But besides that, do you know that you are actually very safe within a plane or within a car even when lightning strikes the car or the plane? Okay, but and that is the same idea as what the people in the video has said. When you are in a car and somehow there's electrical wires touching the car, what's dangerous is actually outside the car, because that's where the electricity will travel, outside the car. If you stay within the car, you are safe. The danger is when we open the car door and we touch the floor, and if we are in contact between the car and the floor, that is super dangerous when there's a power leak, because we will be the connecting bridge where the electricity will flow through. So find out more about this, about how come we are safe in a car even when lightning strikes the car. Okay, then the point about the substation, the power station, the transformers. Now, we don't see that very often in Singapore. They are often housed beside the rubbish chutes. So if you stay wherever you stay in Singapore, there is this transformer and power transformer thing, which is usually beside the rubbish chute, or in a building that is standalone by itself. So it's all locked, and therefore we don't really see what goes on behind there. And these transformers actually brings the electricity into our house, because electricity is transmitted across power lines at super high voltage, very high voltage, because this helps prevent energy loss. But this very high voltage is very dangerous. And therefore the transformers help us lower the voltage. We say that we step down the voltage of the electricity from a few thousand volts into 220 volts in our power plugs to make it safer for us to use. So that's the function of a transformer. Last point, the power lines in Singapore are not overhead. They are all buried underground. but in a lot of other countries, you will see that the power lines are overhead power lines. So in our home, there are a few devices that help safeguard our safety. And one of the safety mechanism is in a 3-pin plug. In a 3-pin plug, there's this thing called a fuse, and the fuse is always connected. This is the fuse. This is actually the picture of a fuse, very small thing, and inside the fuse is actually a very thin wire, and this thin wire is carefully calibrated, the length, the material, the dimensions, the thickness, so that it will burn away once the current becomes bigger than a certain amount. So when there is a leakage of current because some appliance is faulty or because someone is getting electrocuted, then the current flow will be humongous. When this happens, it will burn away the fuse, and when the fuse wire gets burned off, the whole circuit is broken. This fuse therefore, or this broken fuse therefore stops the current flow, and hopefully can save the person who was being electrocuted just now. A point to note is that this fuse is always connected to the live wire. In a 3-pin connection, there are 3 wires. One of the wire is a live wire where it carries very high voltage, and current will come from the live wire and then it will return via the neutral wire. The earth pin and earth wire is there to as a safety mechanism also, to ground the electrical device, so that any leakage of current because the appliance is faulty, the excess current can flow via the earth wire into the ground. Now, a second device that we have in our household is this thing called a circuit breaker. You might have seen this before. We have you have this in every house. And when there's a blackout, your parents usually will just go to this circuit breaker to switch back on it. So what happens is a circuit breaker is like a fuse, but it can be easily replaced. So when there's a high current drawn from certain parts in our house, the circuit breaker will automatically detect the high current and it will switch off the electricity. This is to safeguard against any current leakage. So what happens if when there's a blackout? This is what usually I would do. I will go to the fuse box, which is the circuit breaker, and I will slowly switch on the switch one by one. Every breaker there, every switch there, represents a certain portion of the house. And when I switch on the switch, if we manage to switch on, it means that that portion of the appliance in the house is okay. Sometimes there will be this switch that whenever we try to switch it back on, it will off again. That tells us that the connection of the appliance in that part of the household has some issues, because when I switch on that switch, immediately the current drawn is very big. That's why it caused that switch to switch off again. So circuit breaker helps us isolate the electrical problem and allow us to know which portion of our house has electrical appliances that is not performing, not functioning normally, that is drawing a lot of current. And when this happens, we often have to call an electrician to come to try to identify and solve the issue. So I've mentioned about the fuse just now. As you can read here, every appliance we can calculate, or the engineers will calculate out what is the maximum current that it should draw when it's functioning normally. And we just find a fuse that has a rating that is slightly above this normal current value, so that whenever the current exceeds the normal current value, the fuse will burn and stop the current from flowing. Whenever we burn the fuse, we must replace it again. We can just buy this at any shops for like less than a few cents lah, a few cents per piece to replace it. So let's take a look at how a fuse works.
An electric fuse is a safety device. It helps avoid short circuits and thus helps in protecting the electrical appliances from getting damaged. A fuse consists of a metal strip or a wire fuse element. When current starts flowing through the fuse element, heat is generated due to resistance of the fuse element. The fuse element is constructed in such a fashion that when normal current flows or a small current spike occurs, it does not cause the fuse element to attain a high temperature. But when the current load is too high, the fuse element rises to a high temperature and melts, thus breaking the circuit and in turn saving the electrical appliance from damage.
Alright, so that's how a fuse works, with a very cute animation.
An electric fuse is a safety device.
Okay, so circuit breaker, this is not the one that we have gone through the last few years. Now it's an actual circuit breaker. Actually, the function of this real circuit breaker is the reason why the government use circuit breaker as a name for the lockdown that we had in Singapore last year or 2 years back. Okay, so circuit breaker, like what I've said just now, you have one in every household, and there are many switches in a circuit breaker. Each one represents a different part of the household. When the current flow is very big because there's a faulty appliance, the switch will trip and turn off. This will cut off the current and cause a blackout in a house. So unlike a fuse, the residual current circuit breaker can be easily reset by just switching up the switch once you remove the faulty appliance. Let us now take watch a video to see how a circuit breaker works.
Power outage again?
When we experience a blackout, we are actually being kept safe by circuit breakers. The circuit breaker is a safety device that switches off the electric supply when there is too much current flowing in the home appliance. How does the circuit breaker work? What you see here is a consumer unit commonly seen in a HDB flat. And this is a single circuit breaker. When we open it up, its components look like this. To help you see the components more clearly, let's use this simple animation instead. A circuit breaker contains the switch we see from outside the circuit breaker, which is attached to the safety bar with spring 1. This spring makes the safety bar move out to break the circuit when the iron latch is released. A soft iron latch with spring 2. This spring locks the safety bar in position under normal working condition. Two electrical terminals which are connected to the live wires. Current flows in and out of the circuit through these terminals. And lastly, a solenoid. We will see how the solenoid works later. Let's see the circuit breaker in action. What I have here are 3 electric kettles connected in parallel to a power source. When I switch on the first electric kettle, the circuit breaker does not trip. When I switch on the second electric kettle, the circuit breaker still does not trip. Let's see what happens when we turn on the third electric kettle. It still does not trip. Let's add an electric kettle of a higher power rating to the electric circuit. Seconds after turning it on, the circuit breaker trips. Why does the circuit breaker trip only when this kettle is connected? Let's find out. When three kettles are connected in parallel, the total amount of current is below the rating of a circuit breaker. In this situation, the soft iron latch stays in its position. Spring force 1 and the solenoid magnetic force is not strong enough to create a clockwise movement to overcome the anti-clockwise movement due to spring force 2 acting on the latch about the same pivot. The interrupt point remains closed and current flows normally through the circuit. When the fourth kettle is connected, the total amount of current exceeds the rating of the circuit breaker. When this happens, the solenoid becomes a very strong electromagnet due to the larger current. At this point, the clockwise movement due to spring force 1 and the magnetic force of the solenoid is greater than the anti-clockwise movement due to spring force 2 about the same pivot. The soft iron latch is attracted to the solenoid and it turns clockwise towards the solenoid about the pivot. The interrupt point is now open and the circuit is switched off. Circuit breaker is a safety device. It switches off the electric supply when the current flowing through the circuit is greater than the rating. This is important to prevent overheating of cables and hence prevents electrical fire due to an electrical fault or overloading. As the saying goes, prevention is better than cure. Although circuit breakers keep your home safe from electrical fires, you should always ensure your own safety by not overloading your power points.
And now you have seen the use of electromagnet in a circuit breaker. Alright, and in the last slide over here, we can see that in hospitals, when we cannot afford to have a blackout, because there's life support machines that needs to be powered with electricity all the time. There's often a dual power system or even triple power system, and in the event that there is a blackout in the main power grids, this secondary backup power system will kick in, and to supply the electricity for a while. We actually have this thing called UPS, uninterrupted power supply, and you can just buy this off the shelf at some computer shops, and which performs the same function also. In the event that there's a blackout, this UPS provides power to the computer system to keep it running. However, this UPS can only supply energy for a short while, and this is how we can ensure that hospitals or critical computer equipments can continue functioning even when there is a blackout. And so with this, I've come to the end of this section. Please complete your activity book 13.3.2, and I will see y'all back in school again.